Today, we will continue our fractions, decimals, and percents series by looking at digits and decimals. In this chapter, we will look at introduction to digits and decimals, place value, powers of 10, decimal operations, terminating versus non-terminating decimals, and unit digit problems. It is important to take note that the exam will test your ability to understand numbers that goes beyond understanding of the properties of integers. Now, a digit is a single symbol used to make numerals. We use 10 digits, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 in everyday numerals. Example, the numeral 712 is a number composed of 3 digits, 7, 1, and 2. We classify integers by the number of digits they contain. So for example, 3 and negative 4 are each single digits. 21 and negative 51 are each double digit numbers. 600 has 3 digits and 400,000 has 6 digits. Now, non-zero integers are not classified by the number of digits they contain. Now, since you can always add any number of zeros at the end on the right side of the decimal point. So if you have 2.5, you can add 1 0, it becomes 2.50. You can add 2 zeros, it becomes 2.500. They are the same number. And so we do not, classify non-zero integers by the number of digits they contain. Now, let's look at decimals. Decimals are numbers that fall in between integers. So for example, you have the numbers that fall between 0 and 1 are 0.1, 0.2, 0.3, 0.4, 0.5, and so on. And so if you look at this number line right here, you have, the number between 1 and 2 being 1.5, and this makes this one, a decimal. We can also look at, decimals that are less than -1, decimals between -1 and 0, and decimals between 0 and 1, and decimals greater than 1. And we have examples for each right here. Now we'll turn our attention to place value. Place value is the various locations of the individual digits within a number. For example, in the number 721, the digit 1 is in the ones or unit place. The digit 2 is in the tens place, and the digit 7 is in the hundreds place. Okay, so if you look at this, 1 is worth 1 unit, 2 is worth 2 tens or 20, 7 is worth 7 hundreds or 700. Therefore, 721 is 7 times 100, 2 times 10, plus 1 times 1, which makes up the number 721. Now, this chart right here analyzes place value for all the digits in the number 792,346,874,532.5487. And so here you realize that this 2 is right here is in the unit place. This 3 is in the tens place, all the way to 7, which is in the 100 billions place. And then when you go here, you have, when you go to the right side of the, decimal point, you have 5, which is in the tenth place, 4, which is in the hundredth place, to 7, which is in the 10,000th place. Now, note that the place value of all digits to the left end with S. So you realize that here it all ends with S, and the place value of all digits to the right end with THS. So THS. So you take note of that. So here we turn attention to shifting the decimal by powers of 10. Now, place values continually decrease from left to right or right to left by powers of 10. Now, understanding this can help you manipulate the following shortcuts for multiplication and division. So when you multiply a number by a positive power of 10, you move the decimal to the right by the specified number of places, and this makes positive numbers bigger. So we have example here where you have 4.2361 times 10 exponent 3. Now, because we are multiplying 4.2361 by 3 powers of 10, we will shift the decimal point to the right 3 times. So here the decimal point will shift from here to here and then from here to here. And then the resulting solution is this, 4236.1. Now, dividing a number by a positive power of 10 will yield the opposite result of multiplication. So here you move the decimal to the left by the specified number of places, and this makes the number smaller. So in this example, you have 4.2361 divided by 10 exponent 3, and because we are dividing 4.2361 by 3 powers of 10, we shift the decimal point to the left 3 times. So here you have 1, 2, 3. So here you have 2 zeros, and then the decimal point will appear, and then this yields this result. Now, what happens when we deal with negative powers of 10? Here you will have to reverse the regular process. So here you have 4.2361 times 10 exponent negative 3. Now, because you have 10 exponent negative 3 here, negative power, this sign will change, and then this will become positive. So here, instead of this, you will have 4.2361 divided by 10 exponent 3, and then you will shift. This becomes like this, and then this solution here becomes 4.2361 times 10 raised to the power 3, and then this becomes like this. So just switch the signs around just to make the change the negative power to a positive power. Now try the following examples here before you move on. Now turn attention to decimal operations. Now to add or subtract decimals, align decimal points, then add zeros to the right side of the decimal to make the length the same. So here we have 34.561 subtracting 125. Here you only have 125, so because there are the numbers beyond the decimal point of 34 are 3, you add 3 zeros just to align your decimal point and to make it easy for you to manipulate your subtraction. Here you have 5.123 plus 321.4. So you add 2 zeros to 321.4 just so you can align your decimal point to make it easy for you to do your subtraction. Try the following examples here and see if you're able to manipulate and align your decimal point. To multiply decimals, you have to ignore the decimal point and then multiply the numbers as if they were whole numbers. Now you count the total number of digits to the right of the decimal point of all the numbers you are multiplying, and then this total must be equal to the number of digits to the right of the product of the two numbers. And so here you have this example here, 0.03 times 2.3. You ignore all the zeros and all the decimal points, and then you have 3 times 23, which is 69. Then you count the number of what? Decimal places, 1, 2, 3, and then you can shift your decimal point and place it correctly with the number. So here, because you have 69 point to start from here, 1, 2, 3. So there is 1 0 before the decimal point, and you arrive at this solution. Now, what happens if the product ends with 0? For example, 0.6 times 0.5. You ignore 0, the 2 zeros and the 0.5. 6 times 5 is what? 30. So you have this number ending with 0. And so here, when you count your decimal places, you have 2, you have 1 here, and then 1 here. And so moving from, this 30, you have 1, 2, and then the decimal point comes before the 3, and then you have 0.3. Very simple stuff. Now try these two examples here. Now we will take a look at division under decimal operations. If there's a decimal point in the dividend, you have to let the decimal point remain and divide normally. So you have this example 1 here, 14.49 divided by 3. Here you will let the decimal point remain and then you will divide. So 3 will go into 14 4 times, you have 12. Then you have remainder 2, then this 4 comes down. 3 will go into 24 8 times, you have 24. And then here you bring the 9 down. But you have to make sure you place your decimal point here. And then 3 times 3 is what? 9. Using the long division method. Now, here you realize that if we decide to bring certain decimal points here, you can, in a way, multiply by a power of 10 and divide by a power of 10. So here, instead of 14.49 times 0.3, you will have, if you multiply this by 10 and this by 10, you have 144.9 divided by 3, and that gives you this. Okay, and once you decide to use the long division method, this is what you get. So essentially, if there is a decimal point in the divisor, make the divisor a whole number by shifting the decimal point to the right in both the divisor and the dividend. Now let's look at example 3 here. Now simplify division by shifting decimals in both numerator and denominator. So here you have 0.99 times 0.0033. Here we can multiply here by 4 powers of 10 and divide by 4 powers of 10. You get 33 divided by 990. So you can do this to eliminate decimal points. Now let's look at the heavy division shortcut. Now some division problems may look rather complex, but sometimes all we need to do is to find an approximate solution. In such a case, you can save yourself time by using the heavy division shortcut. So what is 1,821,723 divided by this to the nearest whole number? So you have this 1,821,723 divided by 613,400. So here we can approximate this one to 18 and then this one to 6. Okay, by seeing this as zeros, seeing all these ones as zeros, okay, and saying that all the zeros cancel each other, you have 18 over 6, and then approximately, this is approximately what? 3. Now try the following examples here. Now turn our attention to terminating versus non-terminating decimals. Dividing an integer by another integer yields a decimal that either terminates or that never ends and repeats itself. So let's look at this example here. You have 1 divided by 9 is what? 0.11111. Okay, which is equal to 0.1 bar. And the bar above the 1 indicates that the digit 1 repeats infinitely. Okay, we can have another example. 2 divided by 9 will also repeat. It will be 0.22222, which can be approximated to be 0.2 bar, which means the digit 2 repeats infinitely. Okay, now it is worth noting the example patterns in the two tables below, and you will notice that if the denominator is 9 or 99 or 999 or another number equal to a power of 10 minus 1, then the numerator gives you the repeating digits. Okay, depending on whether zeros will begin or depending on the number. Now, so take some time to make yourself very familiar with how these numbers repeat as we have them in the tables right here. Now, because of how special the result is when you divide by 9 or by 99 or another number equal to a power of 10 minus 1, we can convert fractions like 1 over 11 or 3 over 11 to have a denominator which can be easily computed using this rule because we know the pattern. So if you have 1 over 11, you can easily say let's multiply by 9 and divide by 9. Okay, by a placebo fraction, as I call it. So 9 divided by 9, this gives you 9. This 9 times 11 will give you 99. And then you will know that the pattern will be 0.090909. Similarly, you have 3 over 11. We can decide, okay, let's multiply this by 9 all over 9. Okay, by a placebo fraction. And this gives you 9 times 3 is 27. 9 times 11 is 99. And then this gives you 0.2727272727. Okay, so this can help you to be able to simplify fractions or convert fractions to decimals in a very simple manner. Now, let's look at this particular rule. Now, if you divide an integer by 3, by 7, or by 9, and the result is not an integer, then the resulting decimal will repeat. I want you to take note of this. If you divide an integer by 3, by 7, and then by 9, and the result is not an integer, then the resulting decimal will repeat. So 1 divided by 3 will repeat. So this is 0.333333. Okay. Now 2 divided by 3 will also repeat, and this will be 0.666666. Okay, which can be approximated to be 0.667. Okay. Now let's look at 7. If you have say 1 divided by 7, okay, we know that 1 divided by 7 is 0.142857, and this whole number will repeat. Okay, 142857. Sorry, this is 7. And so once you know this, it's easy to know what 2 divided by 7 is, or what 3 divided by 7, 4 divided by 7. And so if you know these fractions, you will be able to do any number divided by 7. Now 2 divided by 7 will you just have to switch these numbers around, okay? And then 2 divided by 7 is 0.285714. So it's just about looking at these numbers. 1 divided by 7. Once you know the standard number, you can know any number divided by 7. Okay, so here you are just switching these numbers around to get 2 divided by 7. 3 divided by 7 is what? 0.428571, and then it will repeat. 4 divided by 7 is 0.571428, and this will repeat. 5 divided by 7 is 0.714285, and then it will repeat. 6 divided by 7 is 0.857142, and this will repeat. And so once you know this standard number, 1 divided by 7, which is like, 0.7 times 2 is what? 14. This is how you can remember 1 divided by 7. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. Then you add what? 7. You add 1. Then you have what? 57. So it's easy to remember this first number. Then any other number you are given, 2 divided by 7, 3 divided by 7, you can easily be switching these numbers around to be able to arrive at your answer. So for example, if you have this number, you are solving a question on the test, and you have 40, and then you arrive at the solution 46 divided by 14. How do you break this number down? Do you have to use a calculator? Well, I don't think so, because if you know these rules, you can easily manipulate your fractions and then solve them into a decimal. So here 2 divided by 14 is what? Is 7. And 2 divided by 46, 46 divided by 2 is what? 23. Okay, so you have 23 divided by 7. Now here you realize that 7 will go into 23 how many times? 7 times 3 is 21. 7, 3, 21. Remember 2. So here you have 23 divided by 7 is 7, is what? 7 times 3, 21. So 7. So the quotient is 3 plus, remember what? 2. 2 over what? 7, the divisor. Okay. Now here, once you know this 1 divided by 7 is 0.142857, you can easily do this. So you realize that this one will become what? 3.285714. Simple stuff. Simple stuff. You don't have to calculate. If you become very familiar with this, you don't have to calculate. We already know the rule for 9, and so 9, if you become familiar with this rule right here, you will be fine and you don't have to use your calculator. Now let us turn our attention to non-repeating decimals. Now there are numbers like root 2 and pi, which will never end and they will never repeat themselves. So on a test, they usually ask you to approximate for these. So here root 2 is 1.41421355, all these numbers, but you can shorten this to 1.4. Now root 3 is 1.7. All these numbers you can approximate to 1.7, and then pi is what? 3.14. Now let's look at terminating decimals. That's decimals that will end. Now these are decimals that the denominator is usually some positive power of what? 10, which are composed of 2s and or 5s as prime factors. If you reduce the fraction and the denominator has any prime factors beside 2 or 5, then its decimal will not terminate. So essentially, if you divide any integer by 2, 4, 5, 6, and 8, and the result is not an integer, then the resulting decimal will terminate. Okay, so 2 divided by 10 will be what? 0.2. Now, we turn our attention to unit digit problems. Now, some problems will ask you to find the unit digit of a large product like the one in this example. So here you have, what is the unit digit of 7 raised to the power 2 times 3 raised to the power 3 times 4 raised to the power 3. Essentially, we have to find the unit digit of this product. Okay, so here, to solve this problem, only pay attention to the unit digits of the numbers you are working with. So you have 7 times 7, okay, is what? 49, because this is what? 7 squared. 3 cube is what? 3 times 3 times 3. 339, 93, 27, 27. So these are the numbers we will pay attention to, the unit digits. Then 4 cube will be what? 4 times 4 times 4, which is what? 64. Okay, and so we have 9 times 7 times 4 is 252, and therefore the unit digit of this product right here is what? 2. Now, try your hands on the following examples right here, and this brings us to the end of digits and decimals under fractions, decimals, and percents. See you in the next video.